Hello, everybody. I'm here to talk about Sauron. I have a disclaimer for y'all. You're about to be on the internet. This little robot here is going to take pictures of you and put you online. If that makes you angry or sad or frightened, you should not be here instead of here. Also, maybe if you were like right there, it might not get you on the camera. These images will be dumped into an S3 bucket on my Amazon account and otherwise displayed on a website behind a password. So that's that. You had your warning. That was your only chance to run. So my name is Jonan, and I work here at New Relic. I don't think that's a surprise to anyone. I'm going to talk about Sauron today. And I am LeetBot on the internet. This string of numbers here, for anyone who knows what LeetSpeak is. And if you don't, you should go to Wikipedia and look it up, because it was quite funny. Actually, it was never really that good a joke, but I'm still LeetBot anyway. And I'm going to keep it forever. So I'm here from Portland. This was more relevant in San Diego. I don't think this surprises anyone. And I work as a webmaster for the Cedar Hills Kindergarten and Preschool. It's a cooperative out in Beaverton. Mostly involves managing mailing lists. If anyone needs to be added or removed from a mailing list, or reminded not to reply all, then I am your guy. So I take my webmaster responsibilities pretty seriously. I also work here at New Relic on the Ruby Agent team. And Ben and Jason and I, are all three on the Ruby Agent team. We're down one right now. So if you would like that job, talk to Tim, again, the guy waving his hand over here. Come and get it. We would love to have you. So if you also have other questions about those jobs, you can find more jobs at the bit.ly nerdlife link that I have set up and become one of us. So I kind of tricked you when I said I was going to talk about Sauron. I want to talk to you about my knife set, actually, if that's okay. I really like my knife set. It's a Ginsu knife set. It's not like the old Ginsu commercial ones, what do they call those? Infomercials. It's not one of those. It's a nice Ginsu set. It was cheap. It was like $72, and it's very highly rated on Amazon. There are 790 reviews, 4.5 stars. And they're really a nice set of knives. I have a lot of Ruby programmer friends who have really nice knives. I think they're called Shun knives. You guys heard of these knives? Anyone here own Shun knives? It's a very popular thing to own Shun knives. So my friend Ryan was telling me how he had his Shun knife sharpened. The company's here in Oregon that sharpened them. And then he was just dragging it across his skin, and he took off all of the hair and some layers of skin as well. So I prefer knives that I can't accidentally decapitate myself with in the kitchen. And also, they're cheap, which is very important to me, because my children literally eat $100 bills. Here's a picture of my children eating $100 bills. This is them right now. They were pretty excited about being in my presentation. I also like these knives because they hold an edge. They're soft enough steel that you can sharpen them yourself real easily, and they hold it for a long time, right? So I've got a couple of sharpening blocks. My friend Rain gave me one. I bought one. And I can sharpen up my knives and keep a nice set of knives around the kitchen for $70. But sometimes this happens. And these particular knives, when you leave them wet in a sink, not only don't hold their edge, but they occasionally rust, and they definitely chip. And I know that I am not the one leaving the knives in the sink because I don't do wrong things. And my wife claims that she also washes the knives after every use, and the children are too young to reach up and grab the knives. They're behind the sink. Because if they're not, I wouldn't have children today if we left them too low. We hide all of the dangerous things. So I was out to solve the mystery of the knives in the sink, right? And I'm sure, I was thinking, and I'm sure you're thinking exactly the same thing, it's got to be Sauron, right? Clearly, Sauron, who loves sharp things and home invasion, is breaking into my home and dirtying my knives and leaving them in the sink, right? To perpetrate his evil plans. So I have a solution. I've trademarked the solution. I'm currently in negotiations with Groupon over some lawsuit business with the trademarking, but I think it's going to be fine. And I'm writing a gem called Sauron. And Sauron is a gem to build out a home surveillance system that is going to use Ruby to monitor my home and catch Sauron breaking into the house, right? So I started my gem happily along. Yes? It can be used to surveil any house where knives are in the sink. If you also have this problem, then you can download Sauron and solve that yourself. The solution is Sauron. But Sauron, unfortunately, after I got started, I got a few hundred lines of code into this, and I discovered that I had a squatter on the name of my gem. where squatter is defined as someone with a useful, valuable Ruby project for the community. And my gem deserves their name for no good reason. Actually, this is a gem that speeds up your automated tests with multiple databases and workers. And that sounds useful. I don't know why he chose Sauron as the name, but he did, so I can't have it. So I changed the name of my gem. My gem was then known as All-Seeing Eye, which I thought was quite clever, right? Except that some other jerk with a real project took that name too. And this one is actually really cool. It observes all requests with params you specify and puts them in Redis, and then it builds graphs out of them. So that's actually kind of a relevant name, All-Seeing Eye. I like that, and I may use that gem someday. That sounds useful. But then I, of course, settled on the best name, which I should have come to in the very beginning, the All-Seeing Pi for my gem, because I'm using a Raspberry Pi. So it just makes sense. This here is a Raspberry Pi. It should be winking at you eventually. Someone tell me if you see a red light blinking. Yes? All right, the demo may actually work. I'm not sure. I can't guarantee anything. This is like a terrible house of cards made out of chewing gum and garbage. The code is really bad. But if it does anything at all, I'll be quite pleased with myself. So this is a Raspberry Pi. Some of you are familiar with these. They're very tiny computers. I've got one up here. You can come have a look later. They're like that big. And you can do all sorts of lovely things with them, including plug a camera into them and take pictures of things. And so I got myself one of these cameras, and I got it plugged in there. You just plug it right in behind the Ethernet port. It's actually very easy. And then there is a command line utility you can use to take pictures with your new Raspberry Pi. So that is one of the components of this system. Obviously, whenever I build anything, I need to involve the clouds, preferably clouds over Mordor, if I have a choice. Mordor is my favorite cloud provider. So I've got the clouds, and I've got the Pi, and I've got the Palantir. And the Palantir is an application that's going to consume the pictures coming off the Pi, because Pis are not super strong, right? They're great, but they're that big. You can't expect a whole lot of computing power, right? So I want to get offload as much of the work of my application and my whole structure onto the Palantir as possible. And Palantir, naturally, is going to be a Rails app because of the Lord of the Rings train. You guys remember the train. No? Nobody remembers the train? I thought that the Rails theme was really there for Lord of the Rings because of the Lord of the Rings train. It lights up on the front, and it has an Eye of Sauron that shoots lasers as it drives. It's awesome. If anyone's looking for a Christmas present for Jonan, hook it up. Okay, so we have the gem, All-Seeing Pi, right? All-Seeing Pi is going to take the pictures from the camera, and it's going to send them up to the clouds. That's all that the All-Seeing Pi is going to do. Takes the picture, sends it to the cloud, right? And this is my architecture plan from the beginning here. I'm going to kind of walk you through my thought process and why I made some of the decisions that I made. So hopefully you'll forgive me someday for what I've done. And then I had this theory that I would have the Palantir kind of polling at the bucket, right? I know I'm probably going to use S3. I've got some kind of cloud storage for those images. Picture taken from the camera goes to the Pi uploads it to the cloud, and then Palantir just sits there and kind of bangs at the door, right? Waiting for new photos. It seems to make sense, except that polling is kind of terrible. There are a lot of things that can go wrong with the intervals, and don't do polling if you can help it, right? A lot of the stuff we have to do with front-end now is mostly polling until we get a better solution. But this is not something that I wanted in my application, right? So I started thinking, like, okay, I need a way for Pi to communicate to Palantir that a new image has been uploaded, right? So I could just put a queue in there, right? So I have a queue that when I upload the image to the cloud, I drop a message onto the queue. I could even drop a job onto the queue, and then Palantir could pick up the job and run it, and it would pull down stuff from the cloud. As all of you know, I'm sure, queue does not belong in this universe. And so I decided to scratch the queue and go with an appy. Does anyone else call these appies? I'm just curious. If you're here, raise your hand. I really want to know. There's one of them. Okay. Appies, what I would call an API, I want to write an appy instead, because there's really no use for the complexity of the queue. I just need an API, and that's what I thought I would do in the first place. But I thought, well, I don't really need the Raspberry Pi to do two things. I'll just have it do one thing, right? I don't want it to have to upload to the cloud and push the thing onto a queue and hit an API. But in the end, I gave up, and I conceded that I needed to have this API call, so that the app on the other end didn't have to do the polling, right? So now Palantir receives an API hit with a little payload that contains the image name. And I was really, because I'm doing two things, and I really don't want the Pi to do too much work, I want to keep this very simple, right? So I'm just going to send over the image name at first. And the image name, as luck would have it, contains the directory name and the key name for the file in the system, right? So I can actually get the directory, which I need for another reason, and I can use the key, and I can pull all of that just out of this one string. All that I have to send over the API is just the one string, right? So then the Palantir can get the API hit and go to the cloud and download that image. With the bucket name and the key name, it can go to that bucket and download the original image that was up there, right, with just the public URL. So I could have the Pi get the picture, send it to the cloud, send an API hit over to Palantir, and Palantir would go and grab the image from the cloud and download it, keep a cache of those things locally, right? And it occurred to me that I was doing a lot of pushing and pulling of images for no good reason, right? I have a certain amount of data that I need from the images, and Palantir was supposed to be the one that was doing all of the calculating on those images and trying to detect changes and things. But I could just get the information from the image before I push it up to the cloud, and then I never have to grab it again. So I decided to keep it everything instead of keep it simple in this case, and get all of the data, the URL at EvoCloud for my JPEG, and then the directory doom and the p-hash, and that's really all the data I need. I don't have to pull the image now if I have all of this. So I want to talk about that p-hash thing. Some of you have probably heard of p-hashes before, maybe, by show of hands, who knows what a p-hash is? Good. Actually, get to teach some people some things. Mike might know over here. Yeah. So what is a perceptual hash? Perceptual hash is a fingerprint of a multimedia file derived from various features from its content. This is from phash.org. And it's actually relatively concise for a technical explanation of a thing and also incredibly vague. I have a better one, right? I say it's a number. That's easier to remember, at least. So this is a number, and this is a p-hash. And I'm going to walk you through how a p-hash is generated here real quick. So we generate p-hashes from an image, and that number is designed to represent how that image looks to you, to the human eye, right? So the way that we do this is we take the image and we smash it. We YOLO smash it. We don't care about any of the pixels and the colors and the sizing and all of those. We're just going to make it an 8x8 right away, right? Because smaller images are easier to work with, and we want this to be fast. We just make it an 8x8 pixel image as fast as we can, right? And so then we've got this colored image, and the color data actually turns out to be kind of useless for what we're doing, so we immediately make it grayscale. And now we've reduced the number of options for each of these pixels. We can only have 64 different shades of gray in this eye of Sauron now. So the eye is now smashed down to a grayscale 8x8-bit image, or 8x8 pixel image. I gave away the punchline a little bit there. And then we're going to take the mean of those grayscales, and we're going to take everything below the mean and make it black or white, or everything above the mean and make it black, right? So those can now be binary values. And so this black and white image that we have that's smashed down, I can turn into a binary number where I just go to the top left corner and I start counting my pixels. And I've got 3 black pixels, so I get 3 ones. And then I've got 3 white pixels, and I get 3 zeros, and 2 more black pixels, and like that, right? I go across the top. And actually, if I line this up with the image, you can kind of, if you squint a little bit, you can see an eye. Do you see the eye? That's pretty cool, right? So now I have this big binary string that is that image, right? And more importantly, in order to get this string to be significantly different from another string that I generate from a similar image, that larger image has to change rather a lot, right? The colors have to break across that mean, and I have to change the outline generally of that larger image, such that when I smash it down to 8 pixels, it's going to be very different, right? Generally, 2 p-hashes are considered to be different if they are 10 apart, right? So here we have a p-hash, and we can, to IOT, we can interpret this as binary into a big number, and that's how we got our number that we had before. So this is how p-hashes are generated. And I am using a gem called Fashion for all of my p-hash generation, and it was written by this guy, Mike, and you can talk to him about it, and it's fantastic. He thinks that this Sidekick side project thing that he's got going on is the big deal. Fashion is where it's at. Go check out Fashion. It's awesome. Ah, he's a fashion designer. Okay. It's this terrible joke night at PDXIB. Okay, let's talk about detecting change between these numbers. So how are we going to tell when the numbers are different, right? And I'm going to use Hamming distance. People are familiar with Hamming distance by show of hands? Some of us. Okay, I have a definition for you, fear not. In information theory, the Hamming distance between two strings of equal length is the number of positions at which the corresponding symbols are different, from Wikipedia. Again, much better than Wikipedia generally does with technical definitions. I can shorten it, differentiness. This is the differentiness of the two strings, and not the numbers. Remember, I turned it into an actual integer at the end there. We're talking about the differentiness of the binary, right? The representation of our image in binary. How many of those zeros have to change into ones to get from one image to another? And if that is more than 10 things, then we consider it to be a different image. So that's how we detect change, right? So the Hamming distance of these two is 1. Hamming distance here is 3, right? And then we can use this image to compare it to another one and see if something significant has changed. All right, so let's talk about the components of the system again. We have the all-seeing pi, and the responsibilities of the all-seeing pi include taking the picture and sending the picture to the clouds and making an API call over to Palantir. And that's all that the Pi does, which is kind of a lot for a Pi, to take these pictures and save them off and upload them to the cloud. And if you don't have a fast enough internet connection, all hell can break loose. But in this case, it's usually fine. So Palantir's responsibilities. Palantir, again, is the Rails app on the other end that is getting the API hit from the Pi. It says, hey, I've sent you a picture. And Palantir has a couple of jobs. It has the UI. So in your browser, when you load up the Palantir application, you've got a little bit of JavaScript that's just looping and showing the images. It's just polling an API endpoint and getting the images. So it's going to show people everything. Then you have the checking of the p hashes, right? We check the p hash against the previous p hash when it comes in, and it's either okay or it generates an alert. And if there's an alert, that means that something's changed, right? We're now over 10. So we got to do something about it. So when we generate an alert, we talk to the cloud about it. We say, hey, cloud, go make us an alert bucket. So normally when the Pi is uploading the images, it's putting them over here in this pile, right? And we don't want that pile to grow unbounded, so we kind of clear it out every once in a while, right? But if we have an event, if something actually happens, if Sauron comes into my house to dirty my knives, I want to take pictures and save them forever. So I create a new event bucket, and I start storing the images over there. And I copy all the images in the cache over as well. So now I've got to create that event bucket. And finally, Palantir notifies me of what's happened here. Me and Ben Sidehead growing out of my head. This is one of my favorite photos of myself. Thanks for that, Ben. And then it also has to delete the images out of the cloud so that I don't get a $10,000 S3 bill at the end of the month. I don't think I could actually do that. I have no idea how much data you'd have to store in S3, but that's a lot. So it deletes the images. It keeps the little bucket with the images from the Pi small. I think it's like 10 images it keeps around. When it gets to the 10th image, it deletes the oldest one, moves on. So the cloud responsibilities in this architecture. This is the cloud, and the cloud's like, I can do stuff, and I'm like, no, you cannot. The cloud has no responsibilities. It is a cloud. And AWS is really excited about adding services to their platform and giving you all kinds of functionality that comes along with it. Like that queue thing that I wanted, I could have used a service at AWS to do that. They want to do that to create lock-in, right? It's the same reason that T-Mobile wants to finance your accessories so that you stay with them forever, right? And I'm not going to lie, I've financed accessories at T-Mobile because I like them. They're great. But in the case of AWS, I'm not positive that I want to stay there. So I have this AWS SDK example of a similar thing going on in my application. I'm using the GEM AWS SDK to interact with S3. I've already committed to S3, like just kind of makes sense for this project. But at one point, AWS SDK becomes kind of unwieldy. It's hard for me to use. And there was a particular problem that I ran into where like I was getting kind of inconsistent behavior on one of the methods that I was trying to call, and I was like, screw it. I'm tearing it out, and I'm replacing it all with Fog, right? And I've seen the insides of Fog, and I've tried to write code for Fog, and it's difficult for me to do those things. Fog is kind of confusing on the inside, and there's a custom testing framework to go along with Fog. But Fog is fantastic to use. And so maybe don't look behind the curtain just this one time, because Fog is really handy. And even better, I get to cut VCR out of my equation. Before, when I was using AWS SDK, I was recording my interactions with the clouds and then replaying them with VCR in my tests. And VCR is great if it's your only way out. Like if you really need to do that thing, then use VCR because it's way better than all of the other ideas that you have. But if you can avoid using VCR and mock around those things, in this case, Fog actually includes a mock. So you can mock Fog at the top of your tests, and then you have a little Pretensy cloud that you can interact with, and it stores your files for all your tests, and it's fantastic. So I just used the mock from Fog, and my life got a lot better, right? or it was going to shortly after I took out the AWS SDK. I've cut VCR now, and I put this VogMock in there. I decided to add some fabricators, because up until now I had been delaying the use of like actual objects, and all of my artisanal handcrafted test objects were starting to get kind of unwieldy as well. So I cut those out, and I created fabrication objects things, these fabricators to generate my objects for me, because I had more complex interactions between them, and I needed to keep track of that sort of stuff. And then I've got Faker in there, and I'm starting to fake some of the data. And when I start to add randomly generated data to some of my objects in my tests, and this is why you should fabricate objects early and often, then things start to break unpredictably, and suddenly I am lost in the terrible, sad forest of sad, and nothing is ever going to be okay, because I just changed a billion things in my app, and then I went and I ran the test suite, and it was bright red. Everything was broken. I mean, I had like 50 tests, and none of them worked, right? I had broken everything all at once for a lot of different reasons. But I learned an important lesson again, and it's a lesson I apparently have to learn every single time I build anything, and that is do one thing. Just do one thing, and then commit that thing, make your test pass, right, and then commit that thing, refactor, right? Red, green, refactor. A really smart lady named Maureen gave us a talk about that one time. Red, green, refactor, right? I know you think you want to do two things. I know you're like, oh, I've seen these things before. They come in twos. I know it. I can do two things. No, you cannot do two things. Just stop it. It will be terrible, I promise. You'll get lost. So this is the one thing. You're going to do one thing, and you're not going to end up in the terrible, sad forest of sad, okay? So eventually, it probably took me 2 days of evening hacking to get back to life. And I come out into the sunlight, and my application works, kind of. And I get to work. I start building out my API. So I've got this API that I've got to build. I decided to use Grape because we were adding Grape instrumentation for the agent, and I needed to play with Grape a little bit. So I've got this API written in Grape, and the front end is going to pull this Grape endpoint to just get the latest image, whatever latest image comes up. And then the Pi itself is going to post the images to the API to create an image. I've got an image model in the Palantir application, right? So the Pi takes the API over to Palantir, makes the API hit over to Palantir, and then Palantir is responsible for everything else, basically. Okay? So again, my aim is to keep it simple. All of the things that need to happen inside of Palantir, all of the comparison and the creating and the deleting and like that, I want to keep it very simple. So of course I chose Rails callbacks, right? Because that means simple to me. And so I decided to, yes, there we go. That's what I'm talking about. Have we just started the Twitter, or has it been going on? Yes. Good work, team. Oh, come on. All right, so move my cursor. Oh, you had to go. All right, so we have Rails callbacks here. The Lord of the Rings train. I can't believe that thing actually exists. It's so awesome. I really need a Lord of the Rings train. It's like the Hobbit spoon collection. These are real Hobbit spoons, I promise. All right, so a new image comes in from the Pi. And Palantir gets that hit, and first thing we got to do is create an event, right? Sometimes. We create an event if the image is too different, right? So we've got this callback here, this create event. After a new image is created, I want to create an event, and then inside of create event, I conditionally don't sometimes if it's not different enough, right? So I create an event, good. And then if a new image comes in, I also want to copy that image to the event if one exists, okay? So I've got a new image coming in from the Pi. I check to see if I need to create an event and create it if I need to, and then I copy the image that came in over to the event. So once I've copied it over there, I can go and delete the oldest image, so I only keep those 10 images around, right? If I could help it. And that's pretty much what a new image will do in the system. Those are the 3 callbacks for a new image, okay? So now we're going to talk about creating an event. The first callback on the image creation that creates an event also fires some callbacks, of course. And this is it, right? So we create a new event. And the new event has to have a name. Because names for buckets in S3 are unique, then I need to generate a unique bucket name for each of these events so that I can store my images and have a new event every time, right? For each instance of Sauron coming to dirty the knives, I want a different bucket and pictures of Sauron. So this new event has to generate a directory name immediately, generates the directory name. And then we go and we create the directory. And once we've created the directory, we actually create it up in the cloud, right? That's what the create directory does. So we generated the directory name, we created the directory, and we need to copy all of the old images over to the event as well, right? So we copy images, copy archived images, all of those images that were going into the main bucket, the last 10 images, right? in case Sauron was like slowly sneaking in the door and then tripped and we caught him. Then we can kind of look back at the history there. And finally, we need to assign the last image to the event so we can see the image that created the event. I want the event to be associated with the first image so that I can show it on the event. Right? So that was pretty simple. Finally, we have to send the notification to me and Bonus Benhead, and that's going to be the last of our callbacks there. So we definitely kept it simple, I think. It's just these 8 things that happen in immediate consequence of a single API request. So if I had a chance to do this over again, if I was going to build this app, I would do anything else but that. Like literally anything. I would rather carve my program in stone tablets than use Rails callbacks again for that purpose. It was really terrible. I clearly am like obscuring the need for several business objects in there. And I was going quickly, but bad architecture happens to everyone. When you sit down at your legacy Rails app and you're like, man, whoever wrote this is dumb, that's what someone says next year about you. Because you also probably make bad decisions sometimes, right? It may well be you, yeah. Yeah, very often you do the G-blame. Don't do that. It's not worth it. It's so often you, right? So yeah, I have a lot of ideas. I could have some kind of an object there that takes the API and handles all of the rest of those things. There's a lot of work to be done in that particular area. But I wanted to very much expose the flaws in building this application because I think there's a tendency when we talk about our code to look like we were just born spewing golden codes out, right? And it makes us all look really, really smart and also is very intimidating for newbies. So let's be nice and show our flaws too. I really only have flaws to show, so it's not hard for me, actually. Okay, so let's talk about if you want a Sauron. Does anybody want a Sauron for their very own house, right? It's so cool. You need to spend $40 to buy this thing. You may already have a Pi, in which case I think the camera add-on is $15. They have a bundled deal. There may even be like a Black Friday, give us your money prize deal right now. What's Cyber Monday? Yes. I'm a really good shopper. You have a question? I am using a B. The B plus is out now. The bundle is an A, and the A is fine. You're not doing very much. The A will run Ruby. You put noobs on there, and you can have a Ruby, and then you just plug your camera in, and you're good to go. It's not doing a whole lot of work. Yes? It didn't yet catch Sauron. It was me. I sometimes leave knives in the sink and blame it on my family and Sauron. I'm kind of a bad person. I'm getting better, though. My wife has evidence now, thanks to this machine. So you can buy a bundled A and camera on the Raspberry Pi website for $40. It's a good deal. And then you can get the app Palantir on GitHub. I have released this under an MIT license. Read the part about no warranty very carefully. This may very well blow up your house and everything you love, and it's not my fault. The code is terrible. We're taking pull requests. And All Seeing Eye was the original name of the repo, but I had to change it to All Seeing Pi. So this is the place where you will actually find it. And then I hopefully have a demo thing to demo. Let's see if that did anything. Was there a tweet earlier? Anyone see a tweet at PDXRB? That would be a good indication of you on the internet. That's Palantir taking pictures of you, or it was at some point. Now, there it is. It's refreshing. These are the latest images of y'all coming from this camera right here. And people in the back can wave and jump around, and we may be able to generate an event. What is more likely to happen if we try this is that it will inexplicably stop taking pictures. I'm not sure why that happens. But if anyone has an idea of why a PyCam would take a bunch of pictures, and then if one picture was too different, stop taking pictures and hang forever, then please let me know. But let's try it. Everybody stand up and look different and see if we can get a picture. Is it maybe going to take a picture? It goes pretty quick. How long does it take to upload? No? Yeah, this is, I think, exactly what happened. We broke it. Well done, team. Yeah. This is the same thing that happened at RubyConf. I don't want you to think you got an inauthentic experience. This is exactly how the RubyConf presentation also went. Fortunately, the presentation holds its own. So after a demo, I have to find a cursor over here. Go, 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 go. Do it. All right. So I want to talk about the future of the project a little bit. I would like it if there was a faster setup. Ideally, I would like, I'm sorry? Oh, it blinked again. Oh, good. It's taking pictures now that you've all settled down. I'm serious. That's exactly what happens. Someone needs to help me figure out. Right. Good job. Yeah, all-seeing Pi of worthless. I really need help with this. I'm stumped. It does compare the images on the Pi. Yes, if it... That would make a lot of sense. There is very clearly, this is why Marcus is a better programmer than me. Among other reasons, yeah. Oh, that's exactly what's happening. Sauron is controlling the system. That didn't even occur to me. Marcus, I reject your explanation. It's Sauron, the ghost in the machine. Okay, so I'm taking a separate code path when I notice that the image is different and some error is being raised, and I'm not doing anything until I recover. Of course, that's what's happening. Okay, faster setup. I want this to be very easy to set up so you can avoid problems like I've created here with my artisanal solution on the Pi. Like I installed the gem, but it's actually pretty hard to install. You've got Nokogiri as one of the dependencies. Fashion has some crazy dependencies that are pretty hard to install on Noob, so they've got a bunch of other like C libraries that you need to install first. So the installation is difficult. What I would ideally have is an image that you could just put on your Pi, and it would start working, but each one of them needs to be unique. Like you've got to put your AWS keys on there and so on. So maybe I could generate a Docker image that took some of that data in, and then I could send updates to people's Pis for them if they wanted to as well. You don't have a problem with me like pushing software updates to a camera running in your house, do you? Is that? I think it'll be fine. I'm clearly a good enough developer for that kind of responsibility. It'll be fine. So I want a faster setup somehow. I want to get some AI in there. I think that it would be really cool to teach Sauron. Like I can get Sauron to pan. I have some stepper motors that I could hook up. I could get Sauron to pan, and I could teach Sauron what certain areas of the room are supposed to look like. Or maybe like what change pattern for my dog walking into the picture is, like this is an okay change, right? If Sauron disguises himself as a dog, then more power to him. It's worth it. Come on in and dirty the knives. And also I need to fix everything. Like all of it. This is Fix-It Felix costume guy. He's awesome. Oh, and I finally want to add a faster camera solution. So the camera, the blinking red light is about as fast as the camera can take pictures right now. Like that's what it can do. So it runs all of the code and does the uploading, but there's a faster way to do it, and it's this little utility called Raspberry Fast CamD, which is the Raspberry Pi Fast Camera daemon. And this daemon takes pictures very, very quickly, like sub 10 milliseconds to capture a JPEG, and then I could be uploading them up some other way faster, I'm not sure. Whatever I need to do. Sauron is upstairs and banging around now. So the faster camera would help me do a lot of things. I may actually go to video as well, but I don't know very much about like stopping at particular keyframes in video and trying to capture images for the p-hash comparison. So that could be a very difficult conversion, but that may be in the future for the project as well. The benefit of using Raspberry Pi Fast Camera Daemon is that I get to add a daemon to my Lord of the Rings universe project, which I would be pretty excited about. Here's my favorite image captured at RubyConf. This is Dr. Brain leaning down over the camera to say hello. Eric Hodel. So thank you all. If you have questions or comments or concerns, I welcome them.